All right, in this next section, we're going to talk about ethyl groups and multiple representations. In the previous section, we talked about the substituent methyl, which has 1 carbon. So we can see it here in a structural formula, here in a condensed formula. Ethyl has 2 carbons. So here's the condensed form, CH2CH3, or drawn out as a structural formula. Remember that this bond here is the one that bonds to the main parent chain of the alkane. Okay, so we're going to name a molecule with an ethyl group using exactly the same approach that we did for those with a methyl group. So we're just going to take what we previously did and just expand on it. Now, because there's more carbons here, that idea of naming the longest parent chain gets a little bit trickier. We just really have to be careful. The process is the same, but we really have to be careful to make sure we're finding the longest carbon chain first. All right, so example 1, we're given a molecule here, and we're asked to identify and name the main chain as step 1. So let's work on that together. I'm just going to use my mouse, you can see it, to just kind of start counting some carbons. So if I start here, this is always the most straightforward, is just to look at the one that's most obvious. Let's see what happens. So we have 1, 2, 3, 4, 5, 6, 7. Obviously, if we start here and go this way, we also get 7. We can start here and say 1, 2, 3, 4, 5, 6. Already that's not the longest. We could start here and say 1, 2, 3, 4, 5, 6. Also not the longest. Okay, so the longest chain is this one right here. Which is 7 carbons long. So we'll call that heptane. Heptane. All right, the next step is to number the carbons. Now, we can number either from the left to the right, 1, 2, 3, 4, 5, 6, 7, or from right to left, 1, 2, 3, 4, 5, 6, 7. The way we decide is this is a substituted group, right? Because if this was just heptane, there'd be a hydrogen here, but we're substituting here. The substituted carbon should have the lowest number possible. So if I start here, I get 1, 2, 3, 4, 5, 6, 7. If I start here, I get 1, 2, 3, 4, 5, 6, 7. In both cases, this number is 4. So you can start numbering however you would like to. I'll show you in the next couple of slides how we've chosen to do it. So you can see highlighted and explained here exactly what we just discussed on the previous slide. We can start numbering from either end since the ethyl group is bonded to the central carbon atom in the main chain. So the end carbons on the left and the right are equidistant from the substituent. Okay, in purple, I've numbered the carbons, which is the next step. So I've just chosen to start from the left, since it doesn't matter, to name 1, 2, 3, 4, 5, 6, 7. Now, the next thing we need to do is identify and name the substituent. So we can see we have all hydrogens off of most of these carbons, but at carbon number 4, we have a chain right here substituted, and this is 2 carbons long, so we call that an ethyl group. Okay, so that's an ethyl group in green. Okay, so highlighted here in green is that same ethyl group, okay? Now number 4 is determine the carbon to which the substituent is bonded. So I'm just gonna circle it. We can see it's bonded right here to the carbon 4, okay? All right, so we've answered number 4. We're talking about the carbon 4. Now we have to name the molecule. So first we put the number that we have our substituted group, so 4, then the name of that group, ethyl, and then our parent molecule, heptane. So we call this molecule 4-ethyl heptane. All right, so that last step, just to review everything, is to name the molecule 4-ethyl heptane. This slide summarizes each part of example 1. In this slide, we'll talk about the different ways we can represent these organic molecules. As compounds become more complex, it's easier and clearer to use condensed formulas instead of structural formulas. Bond line formulas, which you see at the bottom, or skeletal formulas, are even clearer as compounds become complex. So we can see in this condensed form, we show every single carbon and every single hydrogen bond. In the structural formula, we just show how the carbons are connected, which is important so that we can find the longest chain, but we don't feel the need to draw bonds for every single hydrogen. We can just say how many hydrogens are bonded to each carbon. And in the bond line formula, every angle here just represents a carbon. So we have 1, 2, 3, 4, 5, 6, 7. Okay, so this is the same compound that we see above. We're just drawing lines to represent each of the carbons, okay? You can take a little time studying the 3 approaches just to understand how there are different ways of drawing the same compound. Bond line formulas, like the one you see at the bottom, will be used for much of what we will be studying. Recall that each endpoint or vertex has a carbon, and that each carbon has enough hydrogens to create 4 bonds for each carbon. So in cases with only single bonds like this, end carbons like this one, and this one have 3 hydrogens, and at each of these vertices, those carbons have 2. All right, using this bond line formula that you see, this structure that you see, we're going to identify and name the main chain first. Our end goal will be to name this whole molecule. So I'm first just going to use the pointer of my pen to try and identify what's the longest carbon chain. So if I start here on the left, then I have 1, 2, 3, 4, 5, 6. Now if I go this way, it's 7, 8. If I go the other way, then it's 7, 8, 9. So that's going to be our longest chain. This one right here. Because it's 9 carbons long, we will call that nonane. N-O-N-A-N-E. Okay, so we see now this is our longest chain, nonane. Now in the next step, we're going to number the carbons. And remember, we want to number the carbons starting from the end that's closest to the substituted group or the substituent. So I'm going to start from the right and work towards the left and number 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, if I had started on this end, I would have gotten 1, 2, 3, 4, 5, 6. Okay, and that's more than 4. So we start from the right and go towards the left in this case. So as I just discussed, the numbering begins from the end carbon nearer the substituent. If I start here, I'm 4 carbons from the substituent. If I start from the left towards the right, I'm 6 carbons. So the number needs to begin here on the right. Indicated in purple is the numbering that we saw a couple of slides back. 1, 2, 3, 4, 5, 6, 7, 8, 9, starting from the right and going towards the left. The next step is to identify and name the substituent. So we can see at carbon number 4, we have a branch coming off, right? And we need to determine how many carbons it has. So there's the carbon at this vertex is carbon 4, and then we have a carbon here and a carbon at the end, okay? So we have 2 carbons, which gets the name ethyl. Ethyl. Okay, so indicated in green, like we showed on the previous slide, is an ethyl group. Now, what carbon is that substituent bonded to? If you do the work of numbering your carbons properly, that's already done for you. That's carbon 4. All right, so indicated in red there, you see it's carbon number 4. And if you've done all of the work up to this point, writing the name itself is straightforward. We start with which carbon is substituted, so 4. What group do we have coming off of that carbon 4? We have an ethyl group. And then the name of the parent chain is nonane. So we have 4-ethyl nonane. All right, so we can see here the name of the molecule 4-ethyl nonane. And again, if you start here and just work your way through the steps, getting to that name at the end is pretty straightforward. All right, here's example 3. Our goal is going to be to name this compound that you see in the diagram. Let's start with step 1, identify and name the main chain. So we've got to start counting some carbons here. I'm going to start on this end with carbon 1, 2, use my pointer so we can see. Here's 1, 2, 3, 4, 5, okay. Or we can say 1, 2, 3, 4, 5, 6. Okay, or if I go this way, 1, 2, 3, 4. All right, so the longest chain is this one, right? Here. And just to confirm again, it's 1, 2, 3, 4, 5, 6 carbons long. So we would call that hexane. So here in this example, what was an added ethyl group in the previous examples is part of the main chain in this case, since that leads to the longest possible chain without any backtracking. So this is hexane. Now the next thing we need to do is number the carbons, and you can see there's a substituted chain right here, substituent chain there. Remember that we have to number the carbons so that that substituent has the lowest possible number. So if I start on the left up here, that would be 1, 2, 3, 4. If I start down here, it would be 1, 2, 3. So that's what we'll do. We'll number from down here, 1, 2, 3, 4, 5, 6. To summarize from the previous slide, the numbering begins from the end carbon near the substituent. If I start from the left and go towards the right, then this carbon is 4 from the left. If I start from the bottom or the right, as we've been calling it, and go up or towards the left, then it is 3 carbons from there. So we're going to start from down here. All right, so in purple here, you can see the numbering from that first chain, exactly like what I walked you through a couple of slides back. So now we need to identify and name the substituent. So we can see there's a carbon coming off of here, and there's only one. And so we know that there's one carbon here, CH3, and that is a methyl group. So I've highlighted here in green that single carbon that's branching off of our main chain. And as I wrote on the previous slide, that's a methyl group. Now, what carbon is that methyl group bonded? If we did our work on the previous parts of this question, we've already numbered it, so we can see that it is bonded to the third carbon. Okay, so indicated in red here, I've circled, it's attached or branched off of carbon 3. So now we need to name the molecule. So this is why we do all the work of these previous steps, so we can just very straightforward, without missing anything, say that this is 3-methyl hexane. So the name of this molecule is 3-methyl hexane.